In this video, we are going to look at the factorization of more complex quadratics when the coefficient of x squared here is different from 1. So let's first have a look at one factorized form and see if it's going to change much from what we've seen before. If we try and expand this quadratic here, 2x times x will give you 2x squared. Here you will get 6x, here you'll get minus x, and here you'll get minus 3. So in the end, you get 2x squared plus 5x minus 3. So you see that this number here is still the product of these two numbers, minus 1 and plus 3 multiplied to minus 3. But this plus 5 here is not anymore the sum of minus 1 and plus 3. It's because this plus 3 here has actually been multiplied by 2x and has been turned into a 6x instead of the 3x. So when we have coefficients here in front of the x's, resulting into coefficient in front of the x squared in the standard form, then we can't really apply the method we've seen before, and we need to look at this in a little bit more detail. My suggestion in this video is to first look at one method that is presented as standard method to factorize this, and then look at another one which personally I prefer, and that is a bit clearer about why things work the way they do. Okay, so one thing you are told with the standard method is to multiply the 6 and the minus 5 together. So you know that the product of the two numbers you're looking for has to be minus 30. And the sum still has to be the 7 you have in front of the x. This 30 being 2 times 3 times 5, you don't have that many options. You need one positive and one negative factor, because here you have a negative sign. So if you put the 2 times 5 on one side and the 3 on the other side, you get a 3 and a 10. You see that if you make the minus 3 negative, here the sum of these two is plus 7 and the product is minus 30. So you've managed to find these two numbers. We are now going to change the 7x for minus 3x plus 10x. So let's do this. We have 6x squared minus 3x plus 10x minus 5. You can notice that here we could have also written 6x squared plus 10x minus 3x minus 5. But we'll look at this later. We now need to factorize the first two terms as much as we can. One common factor in these two is 3x, and we get 3x bracket 2x minus 1. If we repeat the same thing for the last two, one common factor is 5. We get 5 multiplying 2x minus 1. And what a surprise, here and there, we get the same factor. So we can now factorize by this one. Okay, so we have 2x minus 1. That was multiplying first 3x and then 5. So we factorized our quadratic, and here is our final answer. Had we made a different choice and written plus 10 before minus 3, let's see what would have happened from that. One common factor here is 2x to the first two terms, so we have 2x times 3x plus 2x times 5. You see, for the last two terms right there, we can't really find a common factor, so we are just going to rewrite this minus 3x plus 5, factorizing by minus 1, basically. You see that once again, we find a common factor here and there. So 3x plus 5 is going to first multiply 2x, and here it was actually multiplying minus 1. We end up with the exact same factorized form as we had here. So we're good. We factorize 6x squared plus 7x minus 5. This method is simple and efficient, but you might be confused regarding the reason why it works. So we'll have a look into a little bit more details at this factorization. What I suggest here is to start again from 6x squared plus 7x minus 5 and factorize this expression by 6. So we get 6x squared plus 7 over 6x minus 5 over 6. One advantage of doing this is that we end up here with a quadratic whose x squared has coefficient 1, which totally relates to what we were doing in the previous videos. And now we are going to look at two numbers that will multiply to -5/6 and add up to +7/6. And we are going to look at these two numbers as fractions over 6. So we are going to look at two fractions over 6 that are going to add up to 7/6, and two fractions over 6 that will actually multiply to 5 or -5/6. The thing is, when you multiply two fractions over 6 here, you do not get a fraction over 6. You get a fraction over 36. So we need to convert this 5/6 here into a fraction over 36. We multiply by 6 here and there, and we get -30/36. What do we end up with? We're looking for two numbers that add up to 7 and that multiply to -30. Remember, this is exactly what we did in the example before. This is why we were looking for the product to be -30. And here is the reason. This -30 is coming from the conversion of this fraction into a fraction over 36. So the two fractions we're looking for, just like we found out in the previous example, are -3 and 10. So now we can factorize the quadratic we have here. Has 6, and the quadratic we had in the brackets now factorizes to x minus 3/6 and x minus 10/6. So you see, it's not quite what we had at the end with the first method, but a little bit of algebraic manipulation will actually get us to the exact same result. Let's first simplify the fraction that we can simplify. Here we get x minus half and x minus 5/3. We can also see that the 6 here can be written as a 3 times 2. And we are going to decide to multiply, let's say, this 2 over the first bracket and multiply the 3 over the second bracket because, you know, we have 4 numbers multiplying each other, so we can pretty much multiply them in any order. From the 2 multiplying the first bracket, we get a 2x minus 1. And from the 3 multiplying the second bracket, we get 3x minus 5. You see that we totally matching the result we had with the first method. This one has one advantage. It's basically using the same method as before. You're just extending it to fraction. And it also helps you feeling more comfortable about using fractions. I hope this helps. And now it's your turn to get some practice.